now we are going to look at all the HTML things in terms of the hierarchy model which we discussed. So I wrote one HTML like this. Now you need to understand, like when you put, so that's why it's better to put indentation. This spacing is called indentation. When you are writing things inside things, which your Visual Studio Code editor automatically does it for you. Let's say you take this part of HTML. Why there is a lot of structure inside it, or to any HTML page, is try to create as many divs as possible, because it's very easy to organize these kind of things. Like how you organize families, so it's very easy to organize. Let's say Facebook or any page, for example. There are so many things. If you try to write everything in the body itself, it becomes messy. So that's why you should build a habit of keeping everything inside one divs and organizing, or maybe you can use sections, the newer format, or headers, footers, and all the things. But generally people use divs because it's come from a long tradition of using divs. And then divs doesn't come with any default padding, spacing, and all the things. So now let's look at this HTML part. So there is div. I gave IDs to it. You can see this div. There is you should understand what is a child node. So the child node is a node that is directly inside the node. So here, if you can see, this is one child node of ID1, and ID6 is one child node of ID1. So ID3, ID4 are also inside ID1, but these are not direct children of ID1. You should understand only the two children of ID1 are ID2 and ID6, because they are inside and the first level. So these are directly inside, and the same way ID3 and ID5 are children of ID2, and ID4 is the children of ID3. So based on this document structure or this HTML code, you should be able to identify who are children, who are not children. So ID4 is not a children of ID2 or ID3. Now you should understand what is a descendant. Descendant is anyone who is inside. So you are a descendant of your, even though you are a child of your father, you are also a descendant of your father. You are also a descendant of your grandfather. You are also a descendant of great grandfather. So in the same way, any level up, you are a descendant, and your father is an ancestor. Your grandfather is an ancestor. Your great grandfather is an ancestor of this. In the same way, when I am referring to a descendant node, a node anywhere inside the other node is called a descendant. Let's say ID2 is a descendant of ID1, ID3 is a descendant of ID1, ID4 is a descendant of ID1. So any element. So that's why now I'm talking in terms of IDs, because these are unique, and these are all called descendants. Now you should know what siblings are. Siblings are pretty much the things which you know. So the children at the same level. So here ID2 and ID6 are siblings, and ID3 and ID5 are siblings. So because they both have the same parent, which is ID2. In the same way, ID2 and ID6 have the same parent, ID1. So ID2 and ID6 are called siblings. So now people saw some common patterns in when you are building web pages, and they came up with something called combinators, which let you write more effective code apart from the selectors which you are using. The first one is called, so these are not actually combinators. So the first two are a bit outside of combinators. So the first is the comma. So what happens is, let's say when you want to put multiple properties, the same properties and same values to multiple classes, you are writing multiple lines of code for each class. So to avoid that, you can use comma. Load. Yeah, it is a multiple selector operator. So previously, how you are writing code is, let's say you want to put padding 10 pixels, font size 20 pixels, and margin 0 for two selectors, div and p. You are previously writing it like this fashion, and you can see you are repeating it multiple times. And it's not so optimized technique. So you can use comma to do all these things. So instead of this, I'm writing a short notation for it. So I need two selectors. It can be type, it can be class, it can be it can be any number of selectors. All you have to put is like join them with comma and then put all the common properties here. So these are some of the techniques which you can use. All the common things, let's say all the divs you want is a particular padding or a font size, or you can use all the things. Then again, you can write extra classes for all the things, and then nobody is stopping you from. So you can see now no property I'm repeating again in using commas effectively. Now I know that for both class 1 and class 2 I need borders. So instead of this, or instead of 2 lines writing it here for class 1 and class 2, I wrote it here. What happens now is any common things you write like in this fashion, if you want to change at any point of time, like let's say why you need to write optimized CSS code or structured CSS code or structured class names is the designer, they might have given you something today, and tomorrow they say, okay, all these boxes which are looking at red, you should make it green. Then it's your responsibility to make it, to change all the things, but it also depends how fast you can change the things. So if it's much more organized and in much more short notation, you can change it quickly. So whenever you are putting, let's say all the borders with 1 pixel, if you write using commas, so whenever he says that all the borders from black change it to red, all I have to change is 1 place, not 2 or 3 places, 2 or 3 classes. Now it changes to all the things. So it is just a way of writing CSS without without defining them the selectors multiple times. At one shot, all the properties you can write separate by comma, and it's much more easy to use. So this is the multiple selectors. Now the next one you are going to look at is type and class selector. So yesterday you looked at a type selector and a class selector. Both are kind of different. So this is how you write a type selector. This is how you write a class selector. But let's say you want to apply some styles for a particular class of a particular type. Let's say you can see all there is div, class 1, class 2, paragraph, class 1, class 2. So everything is same, but you can see the divs, the class 1 is made green, the class 2 is font 30 pixels, it is there, but everything is proper. But what I did is for p dot class 2, this is the syntax, p dot class 2. So any paragraphs of class 2, you can yeah, I wrote the style saying that the color should be violet, the border should be 1 pixel solid. So you can see only this paragraph is changed. Although, I mean, if I comment it out, you can see this div with class 2 and the paragraph with class 2 will look the same. Yeah, this div and this one will look the same in terms of the which is the common elements. So class 2 font size is 30 pixels, div color is red. But as soon as I put p dot class 2, you can see only the paragraph of class 2, not the div of class 2 will turn violet and has a border of 1 pixel solid black. Again, this is a syntax of writing things. You should understand the syntax. Type dot class. I mean, anyhow, you know, for class selector use dot, so you have to put the type on before it. So this in this way, if there are multiple headings and then you can or multiple things with the same class, but you can also now select by types of those classes. It will give you more flexibility in writing CSS code. So these two are the kind of selectors which you can use to write a bit of optimized code or much structured code. Now comes the 4 things which we are going to look today. The first one is adjacent sibling selector. The second one is general sibling selector. The third is child combinator, and then the fourth one is descendant combinator. So these 4 together called the combinators. With this, you can using these 4 combinators much effectively. you'll be able to write much more efficient CSS code. Like I said, people write a lot of divs because of a big page. There can be lot of components or a lot of element boxes over here and there. But if you start giving class names, and typically there will be different persons working on different what I say is the different boxes, let's say, or the different features, and then without writing optimized code, the class names and the CSS will become huge and it becomes messy. So the first one we are going to look at is adjacent sibling selector. Remember the sibling which I told you. So what is adjacent sibling? Is the sibling just below you or below a particular child, or is called as adjacent sibling. So let's say you are number 1 in your family, number 2 is your adjacent sibling. For 2, 3 is adjacent sibling. So why these are put in place is because the way, I mean, so let's say you want you want all the select all the adjacent sibling of something. You can use this. What is the syntax? What is the first one? What is the first element? That sign that is between the separator is plus, and then what is the target element? So, and you can write your styles and properties. So let's look at how it affects. Again, this selector can be anything. This can be class, this can be element, this can be ID, this can be type, or anything. So I wrote some HTML code here. So there's a p div. Again, there is second p, there is div. So this adjacent sibling will affect only the matching of the adjacent. So if I write div plus p, that means all the adjacent siblings of all the p's which are adjacent sibling of div, make them red. So you can see there's a zeroed p, p. Okay. So there is a zeroed p. There's a first div. There's a first p. Now all the paragraphs which comes after div will turn red. So you can see only the adjacent sibling. That means not the let's say the next one just to that selector will turn. So div plus p meaning all the p of after the div will turn red. So this is div. Again, this is div. You can see there is one more p. This doesn't turn red because there is one element between this div and p. So there is one more sibling between this div and this p, which is so that's the reason for the second p not becoming red. In the same way, this p is inside of this div. So this is a children. This is not a sibling, so it doesn't turn red. In the same way, but the third p, which is after this div, it's the adjacent sibling of a div, so that it will turn red. In the same way, fourth p will not turn red because it is it doesn't have a div before it, and in the same fashion. In the same way, you can write adjacent sibling with any selectors. Let's say class 1 plus a. That means any a tag which comes after class 1, it can be any class 1 will turn red. So you can see. So this is a. Does it comes after class 1? No. So it doesn't turn red. This day a comes after class 1. So you can see Masai School 2 link will turn red. This a is inside class 1. So that it's not an adjacent sibling. So it will not turn red again. So the last one is not turning red because it doesn't have any class 1 before it. So this is how the adjacent sibling operator works. Again, the last one I put is p plus a. Any a tag that is an adjacent sibling of a p tag, we will turn 20 pixels. You can see this a tag is not an adjacent sibling because it is before p. This a tag is also not an adjacent sibling because it is again before p. Now, if you write an adjacent sibling here, saying Google it will turn font 20 pixels because this A is an adjacent like sibling of this P. So you can see this Google is of bigger font size. Let me make it 30 so that you can see. Okay. Yeah. So you can see this A which I put new, it will be of bigger because it's an adjacent sibling of P. In the same way, the last Masai School 4, which is an adjacent sibling of this paragraph, will be of 30 pixels. So this is how adjacent sibling operator works. In the same way, there is the next thing we are going to look at is called general sibling. So what is a general sibling is, remember adjacent sibling is that only the next sibling. General sibling is, it can be any sibling below it. So it can be second, third, fourth, fifth. So the you can see so this is the syntax will remain the same. The symbol changes with instead of plus it will be tilde. So for showcasing it, what I did is I took the same code, same HTML, same CSS. Again, let me put the Masai School. Okay. I added one more thing, so let me put this here also, the Google one. So what I did is I took the same HTML code. You can see the code is all the same, not almost the same, exactly the same. The CSS code is also the same. Instead of plus, the only change I made is I made it tilde. So you can see how much different these two pages look. Okay, so there's a lot of difference between these two pages in terms of visual. Now try to understand. So general sibling is any sibling which follows a particular element. So here again, any P which is after div will turn red. So you can see here the second div is black. Sorry, that's where is the second P is black. You can see here the second P being red because it is a general sibling of this div. In the same way that the third P is red here, but the fourth is not red because it is not a general sibling of this div, but whereas in this general sibling case, it is like turning red. So you should understand the hierarchy. So general sibling means any sibling after it will these properties will get applied again. So but these will not get applied for the inside one. So so again the class 1 tilde A. So any general sibling of A will become red. So you can see class 1 is here. So this A will become red because it's an adjacent sibling, and also this A will also become red because this is an adjacent general sibling of this class 1. So here if you look at it, it's blue, but here you can see it's red. But you should understand the children of class 1 will not turn red. This is the children, Masai School 3, it will not turn red. The same way, P tilde A, any general sibling of P, which is an A tag, will have font size of 20 pixels. So you can see this Google has it, this Masai School 4 has it, but whereas here Masai School 1 doesn't have it because it's P plus A. That means this A tag, there is one div tag between these two, but whereas in this case, even if there is a div tag between, because it's a general sibling, these properties are getting applied. I'll just take a. Okay, I'm going to explain you the difference between general and adjacent sibling in a very small example. I'm going to take one div and I'm going to write 4 paragraphs. So for the sake of better visualization, I'm going to write the font size as let's put 24 pixels. Okay, now I'm going to use two properties to showcase this. One is color, one is background color, so that you see the difference of the adjacent sibling and the general sibling. Now, if I use div plus p, so this is, I'm saying it is an adjacent sibling. So any p which comes after a div, and I'm just going to put a p0 before it so that you understand. So this is any p which comes after div, which is an adjacent, which is an adjacent sibling. That means only the next sibling. I'm saying color. I'm going to say, let's say, let me put as blue. Blue is not visible, so let me put as red. So you can see only this paragraph has turned red. Okay. Now, if I use div and I use the general sibling operator, so just to showcase you the difference, I'm going to use a different property. I'm going to use background color. Now I say background green. So you can see only this one, the adjacent sibling operator got applied, and these four, because these are the siblings which come after the div, these will be applied. Now there are two selectors. One is the child combinator, so this will apply to the children of it, and this is a descendant combinator, which is denoted by space. There is nothing you can see, that is space, and this is a right arrow. Child is a right arrow, and you will be able to see the properties being applied for all the things. Now for this, I need some hierarchical structure. I'm going to create it. Okay, now I'm going to create one div. Okay, so I need a hierarchy kind of thing, so I'm going to create one more div. Okay, I'll say ID is equal to ID1, ID is equal to ID2. Now, I'm going to say paragraph here. Now, one more graph here. There are two. Bit more time to think of the examples. So that, okay. So I just created a small structure over here. I'm just going to put a general font size. Okay. Now there are three paragraphs. Now let's look at what is a child combinator. So this child combinator is placed between two CSS selectors. You can choose any CSS selectors. I'm going to use IDs now. So it matches only the elements which are the by the second selector that are children of the first. So these second selector should be the children of the first. Then only it get matched. Then the descendant can be anything. So any like you are a descendant of your grandparent, you are a descendant of your great grandparent, or all the things, but you are the only child of only your parent. In the same way, your parent is the child of your grandparent. So now if I say any children of ID2 which are paragraphs, I'm going to say border 1 pixel solid or dashed green. So you can see only the paragraph 3 has turned to green because these two, para 1 and para 2, are not the what is called as para 1 and para 2 are not the like children of ID1, but these are grandchildren. So these are descendants of ID1. Now, if I put ID1 space P, so that means any descendants, and I will use some property like padding, let's say 20 pixels. Now you can see all the paragraphs got this padding. I'm not going to put border because again yesterday's rules come into place, the bottom one. So I'm going to showcase with a different property. In the same way, if you want to all the children of ID2 to have a different border, you can do that. So you can say ID2 right arrow P, all the paragraphs which are the children of ID2, I'm going to say border you can see red. Again, if I introduce one more div here and I put a para here, okay, para I'm going to say para 2.1. Okay, you can see it has the padding because I applied the padding for all the descendants of ID1, all the paragraph descendants of ID1. So you can see it has a padding, but the border is applied to only the children of ID2. The red one, the green border is applied to only the children of ID1. So this is how, and again, so this will not be applied to siblings. You can see this one is not turned to red and all the things. So I took the same CSS code and the same HTML code for the examples of child combinator and descendant combinator. But in child combinator, in the CSS, I used child combinator symbol, which is right arrow. In the descendant combinator symbol, I used the descendant combinator, which is space. So again, I can't write space. So instead of color, let me put border 1 pixel solid red. So you can see only this got applied, but whereas in the border 1 pixel solid red. Okay, so this div and I say P. So whichever the P inside a div, which is a children of a div, the border would be 1 pixel solid red. You can see this has got it, but in the descendant also, this P is also a descendant, so that it also got the border. Now let's look at the second one you wrote. The second one I wrote is class 1. Any children, any UL which is a child of class 1 will get the font size 20 pixels and text decoration underline. Now you can see this 5 and 6. I'm going to expand these things. So so you can see the class 1 children which are UL and it got font of 20 pixels. Again, this 7 and 8 is a sibling of class 1, so that's why it's not 20 pixels and underline. In the same way, this 3 and 4 is a grandchildren of this class 1, it is not a children of class 1, so that's why it doesn't have that big font size and like the text decoration underline. That's how you are going to select the things. Now, in the same way, any ID2, so any paragraph which is a children of ID2, I set font size 30 pixels, but there is no P which is a children of ID2. It is just a sibling of ID. Sorry, with ID2. Yeah. It is there is no children. It's a descendant of paragraph. This ID4 is a descendant of ID2, but whereas here you can see this is a descendant of ID2. So that's why it's looking the 30 pixels of the font size. So